Hello and welcome back to another episode, continuing session of a Let's Study series. We left off in 3D game programming with DirectX12 at this location in the book in chapter 1.6.7, where we were demonstrating this program which uses the XMVECTOR and vector data types provided by the DirectX math header. And so we're going to be rewriting this program ourselves and making sure that it works. Of course, it's a 99.9% success rate, but we'll see, and we at least get to understand what we need to use these features. So let's open up Visual Studio and let's open up a new project. This will be an empty C++ project. I'll just call this vector trial. Let's add a main.cpp file. And let's include the windows.h, let's include DirectX math, let's include DirectX packed vector, let's include IOStream, let's use the namespace std, let's use the namespace DirectX, and let's use the namespace DirectX packed vector. We'll write an overload function here. Overload the output operator so that we can use cout to output XM vector objects. So this function is going to be returning an OS stream address using the XM call convention, flag, or macro, and with the operator OS stream. So we were taking in two inputs, the OS stream and an FXM vector. We'll define an XM float variable. Labeled destination. We have XM. We'll use the store float function. We'll give a pointer to that destination and the fmx vector v. I messed up over here. And then we want to print out our destinations in parentheses. And let's go to int main. No, I don't know what this is. The iOS base bull alpha. I don't know what it is. And we will check support for SSE2. And if not XM, verify CD support. We want to print that out. Turn 0 if it's not supported, which it should be. And then we're going to do some work. We have X. Who moved the X key on my keyboard? XM vector. So we have a series of XM vectors. We have XM vector 0. 1, 2. Q, U, V, W, one too many. XM splat 1, XM vector set. XM vector replicate. And finally, XM vector splat Z. Then we want to print these out. P, Q, U, V, W. P, Q, U, V, W, and then we just want to return 0. Let's try to give this a go. Interesting. Oops. Zero, 1. Oh, there we go. It appears to be the same results as from the book. That's good. It appears that our CPU does support SSE2. Now I want to explore this. This is cool. Intrinsics. No intrinsics. Client, you need to see CPU ID, CPU information. Okay. So we're checking what is CPU info. It is 4 ints. And we have, it looks like, various ways of getting this information filled out. And if it doesn't fill out, it fails and returns false. So all of the values of CPU info, which is an array of 4 ints, gets set to -1. And so if one of them is -1, the first element is -1, it returns false, such that these failed above it to get information. I think. And it looks like then we use this various compiler preprocessors. x86, x64. We have all these, and they're all defined as machine. So what does this do? What is this? It's a void function. It looks like that function's behavior is dependent on the preprocessor. I'm not quite sure. Okay, and then So we're checking various flags that can tell us that it doesn't support this. So this doesn't, this doesn't, this doesn't, this doesn't, this doesn't, this doesn't. So if any of these flags are not set, and then if the CPU info, we're looking for this hexadecimal. Curious to know. Okay, well, what is this 0 and what is this 1? And 3. Okay, well, we could just assume that this works. Okay, that concludes of recreating this program right here, where we create some XM vectors and print them to the screen using an overloaded function, well, an overloaded operator, which acts like a function in this case. So we have the output operator being used with the XM vector data type, the data structure. I'm on 28. Interesting. It's not something I can look up. I guess it's like a super reserved word. Okay. Alright, this is going to be a short one. I'll just leave it off here. So we use the functions, the XMVECTOR0 function, splat1, a vector set, a replicate, and a vector splat z. The only one that's that could be confusing, I think, is the replicate. The replicate one appears to replicate that value across the x, y, z float. Now, if I did this where it was like 4, make some float 4. Then I expanded this on W. We can see what's actually going on. So we do have that 4th value that wasn't being shown. Splat Z. So X, Y, Z, X, Y, Z, and then splat Z for W grabs that 3rd value and populates it with that. Replicate populates it here. Okay.